Good evening, dear students. Today, at the last class, what we have discussed, we have discussed about your heap-sort algorithms, and also in previous classes we have discussed about what is algorithm, what is analysis of algorithm, what is design of algorithm, and how to analyze the algorithm. For that, we have discussed about different notations, and also we have designed some algorithms like your bubble sort, insertion sort, and also some other algorithms like your heap sort, your phonic number calculation. For that we have also done. Now in the last classes we have discussed some algorithm using some recursive algorithm. That means we have designed some algorithm using recursion. And there is certain disadvantage that if in some cases if you will use recursion, then there will be repeated calculations. And we have not also said what are the other different other type of designing methods. Here there are some type of designing methods leaving your recursive method or recursive design. One is your divide and conquer, as it is mentioned, and second one is your dynamic programming, and third one is your greedy approach, fourth one is your backtracking, and fifth one is your branch and bound. Now, today class we will discuss about one designing techniques, that is your divide and conquer approach. Divide and conquer approach. And in this divide and conquer approach, we will this divide and conquer approach we will discuss, and in this divide and conquer approach we will discuss a particular algorithm, and that is your merge sort. Merge sort, a sorting algorithm, that is your merge sort. Other algorithm using the divide and conquer also we will discuss, that is your quick sort, and also matrix multiplication, one matrix multiplication algorithm, and your mean marks problem. These four algorithms for the time being we will discuss using, which is designed by the help of divide and conquer approach. Okay, hence go to the designing using divide and conquer, that is your merge sort. Now, what happens in divide and conquer? First of all, as it is the name indicates, divide and conquer means first there will be a problem, and the problem will be divided into sub problems. The problem will be divided into sub problems, and that means sub problem means problem having smaller size, and conquer the sub problem. That means solve the sub problem. How we will solve the sub problem? Solve the sub problem recursively. Recursively means, that means in divide and conquer also the recursion is used, and solve the sub problem recursively. Recursively means here what is happening? The sub problem is again solved by using the same method, recursively. That means it is again divided into smaller sub problem. Sub problem is again divided into smaller sub problems, and once the sub problem is reaching to a small size, that means small enough, that means it can be easily solved. That means sub problem will go dividing, and certain point it will come that it may not be further divided, or some point will come, and that the sub problem is easy to solve, and we will solve the sub problem, and the solution of the sub problems, once the sub problems are solved, the solution of the sub problems are combined. That means combine the solution of the sub problems to get the solution of the original problem. This is the approach of designing of divide and conquer. This is the approach of solving the problem using divide and conquer. Hence, now let us consider merge sort. Merge sort, what happens? As we have already told that in merge sort, that means it is a sorting algorithm, and suppose an array is given whose initial index is p, and your last index is r. is given and we want to sort it. And but from the but at the beginning the array A will be from 0 or from 1 in index, it will be indexed from 1 to n. If an array of size n is there, then you have to give in to sort it. Then what in this merge sorter, how the divide and conquer approach will apply here? The n element array is divided into two sub-arrays or two subsequents having size n by 2. That means if the array if the array if the array A what is 1 to n is given, then it will be divided into two sub-array. One will be A 1 to n by 2, another will be A array n by 2 plus 1 to n. Now these two sub-array will be provided, given, and then what will happen? These two sub-array will be sorted. That means concur approaching the same, that means same method. That means it will be again divided, it will be again divided, it will be again divided, and this division will go on until the array becomes an individual element. And once the array becomes an individual element, that means it contains one element, hence it is by default sorted. And now we will, once the subproblem is sorted, subproblem we are getting, solution of the subproblem is sorted we are getting, we will merge it to get the solution of the bigger problem. That means merge two sorted array subsequence to get the sorted sequence. This is the algorithm for merge sort. Merge sort, what is happening? That means if P is less than R, if P, that means an array is given whose first index is P and the whose first index is P and the last index is R. That means if P is less than R, that means at least two elements are there. Then Q is equal to P plus R by 2. That means P is equal, a middle element we will find which is P plus R by 2. Then we call merge sort APQ and merge sort AQ plus an R. Then the merge. That means here what is happening? This is the check for the base case. Check for the base case means once it is reaching to the single element, that is the base case. If P is less than R, that means two elements are there. If P is equal to R, that means one element will be there, hence no need to divide it because it is reaching to the base case. Once we check if the base case has not reached, then you have to divide, and here the division is simple, Q is equal to P plus R by 2. Once you have divided, concur means solve the subproblem, left sub-array, this is left sub-array by using the same method, and solve the right sub-array using the same method. Once the solution of the left sub-array and the solution of the right sub-array we obtain, then the merge two sorted subsequence to get the solution of the sorted array. Hence at the beginning what happened, the merge sort we will call A1n, because at the beginning the array is from index from, that is array is from 1 to n elements will be given. Hence in this case there is a algorithm called merge. Now how really the merging of two sorted sequence happens? You see how this division happens. See, as I have told that this is 1 to 8 by 4, that 2, that means 4, your Q becomes 4 here, and now 1 to 4 is one sequence, and 5 to 8 is another sequence. Now again it is divided from 1 to 2, and this is that means this is again divided into two parts, and similarly this is also divided. Now division is going on until we are reaching to a individual where there is no possible division, and that is called divide. Now what in the concur, what is happening? Concur and merge. See, once it is division, this point we are getting. Now these two sequences are merged in such a way that it will be a sorted, because this one is sorted, this one is also sorted, and we will merge in such a way that these two number will be sorted. Similarly, you have merging in such a that these two number will be sorted. Similarly, the merging of these two is such that these two number will be sorted, because this one is sorted, this one is sorted, and we are merging. Similar cases. Now this sorted sequence and this sorted sequence will merge, so that the final sequence will be merged. That is the job of merge, how to merge it, so that two sorted sequence will be merged in such a that the final sequence will be sorted sequence. And this happens. And in this case, we have discussed that where the number of elements is power of 2. If the number of element is not power of 2, in this example, what happens? This also go on doing it till there is a possibility of divide. In this case, see, divide is terminated here, and but in this case, divide is going up to this, and but in this case, divide is terminated here. The divide is not possible, that means terminated here. Now that is go on dividing until there is a possibility of division. Hence, whether it is a power of 2 or not power of 2, we will go on dividing, and once we have divided, then we will go on merging the sorted sequence. Here they merge in such that it will become a sorted sequence like this. Then this sorted sequence is merged with this sorted sequence, and hence we will get a sorted sequence. Now the job of merge is such that two sorted sequences will be merged in such a way that the final merging will be also in a sorted sequence. Hence we have to study what is the algorithm for merge. Hence in the merge, what happens? We have given two sorted sequences, A P to Q and A Q plus 1 to R, such that the merging happen in such a that the array P to R, will be the sub array P to R will be sorted. The sub array, that means here this is one sorted sequence up to this, and this is another sorted sequence. Now these two sorted sequence will be merged in such a way that this whole sequence will be sorted. Hence, what is the idea of merging? Now we have given this is a sorted sequence, we have given this is a sorted sequence. How will we merge these two sorted sequence to get a sorted sequence? Now to do this sorted sequence is taken to a separate array, auxiliary array, and this sorted sequence is taken to another auxiliary array, and at last minus infinity is placed here, and infinity is placed here. That means this sequence is come to here, this sequence is come to here, and last this infinity is taken. And now here what happened? Comparison will be done from fast to fast. If this one is smaller, then this will go to here. Then the pointer will go to here. And now this and this will be this and this will be compared. This and this will be compared. If this is the smaller, then this will go. If this one is the smaller, this one go. Hence, likewise, the smaller in comparing, the smaller one will go until we are taking all the elements, leaving this infinity and this P infinity to this array. That means these two will be compared, and they will be again placed in the same array. That means here A1, but we will keep placed in the array A. Here is the array, the same array. Here in this array we will place, so that the sequence will be sorted. Now let us consider what is happening in this case. See, here 2 to 7, here we are placing, and here 1 to 6 we are placing, and at the end infinity, and here infinity we are placing. Now this I is pointing to here and j is pointing to here. Now these two will be compared. Which one is the smaller? One will be smaller. Hence this one will go to here, where here. Hence what is happening? You see one is happening. Then once is happening, then j will go to here. Now this and this is compared. Then which one is the in this case they are small, hence anyone can be taken, and the corresponding its pointer will be advanced. You see in this case what happens? This one is taken and taken to here, and its corresponding I is changing to here. Now among this and this will be compared, and among these two, which one is smaller? This one is smaller, and this one will go to here. In the next place, you see, hence what happened here? 2 is going to here, 2 is going to here, and now this one will be advanced to here. Hence this becomes j this, and now again this and this will be compared. This and this will be compared. Smaller 3, hence 3 will go to here. 7, in 7, 3 will go to, hence like this what happens, everything like this you will go on doing until all the elements leaving the infinity are placed in the original array. Okay, now you see at last all the elements are placed in the original array. This is the method of merging. This is the method of merging. Because dividing is very simple, conqueror will call the function itself and solve it, but it is in concur it is going to the what is indivisible unit, and by default it is sorted. Now let us see the algorithm of merge algorithm. This is the merge algorithm. What we have discussed, this is the merge algorithm. What is n1 is equal, because for this, what is, first of all, what is the size of left subarray we have to calculate. Size of the left subarray. Now the size of left subarray is nothing but q minus p plus 1. Now what is the size of right subarray? That is n2 is equal to r minus q. Let L be a left subarray and R be the right subarray, whose number of elements it can hold is n1 plus 1. Here n1 plus 1, that means size is 1 to n1 plus 1, and size of R is n2 plus 1. Why n1 plus 1 and n2 plus 1? Because at the last we have to place infinity here and infinity here. Hence that means two array, left subarray and right subarray we have created. Now this left subarray, this element will go to the left subarray and this element is go to the right subarray. For taking the element from left to left subarray, for I is equal to 1 to n1, that means Li is equal to AP plus I minus 1. That means for I is equal to 1, that means Pi, P plus 1 minus 1, that means this element. That means if I is equal to 1, P plus 1 minus 1, that means AP. AP will go to Li. Li means I is equal to 1, that means this element will go to 1. Similarly, I will be 2, hence this, and P plus 1 minus 1, that means it corresponds to this, and this element will go to this. Like this, how many times we will do? N1 times. That means all the elements will be taken to here. And after doing this, similarly, and similar happen in case of R2, that means all the elements of this will go to your right subarray. Now after doing this, at the end, n1 plus 1 and n2 plus 1, here infinity will be placed and here also infinity will be placed. Hence this is the, what is, placing the left subarray into the left array and the right subarray into the right array. The left subarray is sorted, the left subarray is sorted, and also the right subarray is sorted, and we are going to merge it. Now merge is taking place here. Merge is taking place here. Now what is I is equal to 1? That means I is equal to 1 means I will point to here, and j is equal to 1. That means j will point to here. Then what is happening? For k is equal to p to r, for k is equal to p to r means k will point to where? K will point to p and it will go up to r, and you go up to r. See what is happening here. Again I am explaining. I is equal to 1, that means I will point to here and j will point to here, and your this k points to p to r. That means k will be initially point to here and at last it will point to here. Now this case, that means k will be. Now if Li is less than equal to Rj, that means here in this case, which one? Li is less than Rj. That means Li is equal to, is it less than Rj? No. Hence Rj is less. Hence Rj is less. Hence what will happen? I will be, if Li is less than Rj. No, Li is not less than Rj. Else what is? Li is not equal to Rj. This condition is not satisfying in this case. Hence Ak is equal to Rj. Ak means Ak means here what it will be, what it will place? Ak will be Rj. Rj means j is pointed to here. Hence here what will happen? Here your 1 will be placed. Here will be 1 placed, and j will be j plus 1. J will be go to here. Now again it will go to the loop. Again in this loop, k will be k plus 1. That means k will point to here now. Now k, in the same case, Li with Rj. Li is 2, Rj is equal to 2. Hence what will happen? Ak is equal to Li. Ak is equal to Li means in this k is pointing to here and Li is pointing to here. Hence 2 will be here. 2 will be here, and your I will point to the next element. Hence again k will point to the next element. Hence in this case Li is less than Rj because Li is 4 and Rj is your 2. Hence which one is smaller? This one Rj. That means 2 will go to here. This 2 will go to here. That means in this case we write again 2 here. 2 will go to here and j is equal to j plus 1. That means j will point to the next element. Hence among 3 similar case will happen, k will point to here. Hence again this from 3 and 4, which one is the smaller? This one 3 is smaller, hence 3 will go to here. That means first 1 has gone, then 2 has gone, then 2 has gone, then 3 is going to here. Then 3 is going to here, then j will be incremented. Now among these 4 and 6, which one is the smaller? 4 is smaller, hence 4 will go to here, hence here will be 4 and k, that means k will be increased, here will be 4, hence again I will point to here, hence 5 and 6, which one is the smaller? 5 is the smaller, hence 5 will go to here and I will point to here. And again 6, 7, which one is the smaller? 6 will be smaller, 6 will go here, hence j will point to here. Now infinity and 7, which one will go to? Now the 7 will go. Hence finally what will happen? 1, 2, 3, 4, 5, 6, 7. This is the, what is this? Is the final array A. This is the final array A. This is the final array. And in this way, the merge sort will merge the 2 sorted sequence. Now we will calculate the running time of merge sort. Now first of all we will calculate the running time of merge. See, in this case if you will calculate the running time of merge, this will take say C1 time, this one will take C2 time, okay, this will also take C3 time, constant time. This will take how many times? Cn1 times, this will take Cn2 times, and this will take sorry, I am saying C4n1, C5n2, this is C6, this is C7, this one is C8, this one is C9, and for this, what is time? K is equal to P2, that means it will run n times, this will run n times, and that means this is n times, that means n times it is with constants say C10 into n times, because this for loop will run, this for loop will run n times, hence this is equal to C10 into n, C10 into n. Hence here it is explaining, that means your initialization will take big O n time, because you see initialization, in this case initialization, that means this and this, because this one will be C1 N1, this one will be C6 constant C1 N1, hence it will be C1 N1 plus N2, that means C1 into N. Hence this is the initialization will take big O of n, and adding the element in the final line, that means merging will take also theta of n. Sorry. See, this addition will take theta, that means the merge sort algorithm will take theta of n. The merge sort algorithm will take theta of n. As here we have already calculated, shown you the merge sort algorithm, and that merge sort algorithm will take the time complexity of theta of, sorry, the merge algorithm will take the time complexity of theta of n. Now then what will be the time taken by, in general what will the time taken by the divide and conquer approach? See, let Tn be the time complexity of a divide and conquer algorithm. Then Tn will be, what is, first of all for dividing, let it is taking dn time, plus for conquer let it is a and t n by b. That means here it is partitioning or the dividing b what is, if n element is there, each sub problem will take n by b elements, and there are how many sub problems? A sub problems. Okay, and combining the sub problem is say Cn, hence Tn will be dn and Tn will be a plus bn. This is for what is, this is for conquer, dn this is for divide, Cn this is for combine. Hence the general recurrence relation for a divide and conquer algorithm is Tn is equal to theta of 1 if n is less than a constant, that means n is a constant or less than or equal to c, and otherwise Otherwise it is A into T, A T n by B. What A T n by what it indicates, that means the main problem is divided into A sub problems, and each sub problem has size of n by B, and dn is the time requirement or for dividing the problem, and Cn is the time requirement of combining all the sub problems at that particular point. Hence, in case of your merge sort, what happens in case of merge sort? Dividing is very simple, because dividing, what we have written, Q is equal to P, what we have written, Q is equal to P plus R, you see what we have written in divide, P plus R by 2. In the dividing we have written P plus R by 2. Hence, in the divide we have written Q is equal to P plus R by 2. Hence, it is very simple. Hence, it takes theta of 1, because 1 unit of time. Concur, what happened? Recursively you solve. Hence, in the concur, A, that means why it is in concur this is the case? Because the problem is divided into two sub-problems having equal size, roughly equal size, T n by 2. That means it is divided two sub-problems having equal size. And in case of combine means merging. Hence, in merging it takes, what is? Because in merge sort merging takes theta of n times. Hence, putting together, Tn will be theta of 1 if n is equal to 1, and it will be 2 Tn by 2. This is the for concur, and this is the theta for merge, and plus theta of 1 plus theta of 1. This is for divide. But we are leaving this because theta of 1 has no consequence in the running time of the algorithm. Hence, now the time complexity of your merge sort is can be found by solving this recurrence relation. By solving what? By solving this recurrence relation. If you solve this recurrence relation, then we will get the time complexity of a merge sort. Hence, let us solve this recurrence relation. This recurrence relation can be solved by using master theorem, which we have not discussed yet. We will discuss the master theorem. But now, by what is recursion tree method, we are solving this. You see, so this is the recurrence relation of your merge sort. Now, this can be also be written as, in theta of 1 means we can write C1, and T of 2n, this can be written as Tn 2 by 2. This, now in case of theta of n, we can write C2n, and C1 is if n is equal to 1, and this happens if n is greater than 1. See, now this case Tn will, what happens? That what does it indicates? Tn will go to C2n, that means Cn, this is Cn, and Tn by 2, Tn by 2, because two sub problem having size n by 2 and Tn by 2, Tn by 2. Now this C2n we are writing simply Cn. Okay. Hence, now this again what happens? This will happen. What happens? This is again what happens? Again will be subdivided into sub problems, two divided sub problems, which happen here. Cn by 2 will happen. What happens? Because it's happen, if it is Cn, then Tn by 2 will be C into n jaga, in place of n we have to write n by 2, hence Cn by 2, and Tn by 4 and Tn by 4. Similarly, for this problem we can divide at the same way, that is Cn by 2, and this n by 2 will be n by 4 here, and Tn by 4, Tn by 4. If you go on dividing like this, and like this, go on dividing and again dividing as it is shown here, finally you will come to T1, and which is, if you are coming T1, that means n is equal to 1, it is equal to C1, that means it is equal to C. That means C. That means you will go on dividing, and last you will reach, in every case you will reach T1, and whose complexity is C1, or in simply n. If it is exactly to, if n is exactly to the power 2, then if you do this, that means what is the height of a completely binary tree? If it is height of a completely that is completely binary tree of what is number of node n is log of n, height is log n. That means leaving the root label, how many labels will be there? It will be log n plus 1 labels, but height is log n. Height is log n, but number of labels will be 1. Now, what is the time complexity? The time complexity means what is the time used in this node, what is the time used in this node, all the nodes if you will add, then what will be the result, that will be the time complexity. Hence, in order to calculate the time complexity, the computation in each node we have to add to find the time complexity. Hence, the computation in this label is your Cn, computation in this label is you see Cn by 2, Cn by 2, that means Cn. Computation in this label also Cn by 4 plus Cn by 4 plus Cn by 4 plus, that is Cn. If you will go on like this, if you will go on like this, that means at the lower level it will be this. Hence, what is the, how many labels are there? That is log n plus 1 labels, and each takes how many times? Cn times. Each takes, hence it is equal to C, that means C log n plus Cn times. C log n plus Cn times, as it is there. Hence, the time complexity of mod sort is Cn log n plus Cn times, which is equal to your theta of n log n. Hence, the time complexity of your mod sort is theta of n log n. Hence, running time intensity, the time is intensive of the, hence advantage is that whatever may be the type of input, mod sort will solve the will sort in theta of n log n time. But the disadvantage is that it uses an extra space of size of order of n. Why extra space? Because while we are merging the two subarray from the main array is taken to a separate array, separated two are left subarray and right subarray, left array and right array having size n. Hence, in the disadvantage is that mod sort uses what is extra memory of n. N is the number of elements. Okay. Hence, in this class, I am stopping here about the discussion of mod sort. And remember that mod sort is a sorting algorithm which uses the concept of divide and conquer approach. Okay. Hence, I am in the next class we will discuss about your quick sort algorithm. I am ending the class here.